3, 2, 1.
A very big welcome to Road to Space. We are live at the European Spaceport for the third European launch of Amazon LEO satellites. And today we're orbiting 36 Amazon LEO satellites into space, travelling on board the mighty Ariane 64 rocket. And 36 is the magic number because for the first time, Ariane 6 is flying 4 new and upgraded boosters called the P160Cs, allowing us to transport more Amazon LEO satellites, starting with 36 on this flight instead of the previous 32. So an important first for Amazon LEO and indeed for Europe. Now, over in the fishbowl, we call it, inside the Mission Control Centre, behind the protective glass, the teams are on console, about 16 kilometres from that pad. I'm Katie Haswell, and joining me today is Loïc Leroy from Arianespace, our rocket expert. Great to have you with us, Loïc. Thank you.
Great to be with you here, Katie, and hello, everyone.
And we are looking good for launch right now?
Yes, indeed. All the parameters are green for launch so far. So the teams have been working for several hours now and getting ready for liftoff.
And we're flying our next generation boosters, so it's an exciting day.
Indeed, we have more propellant on board. That means more performance for Ariane 6, more thrust, and it allows us to transport more satellites. So it's always a good thing for our customers and making Ariane 6 more competitive on the heavy lift market.
Absolutely. Right now, flight number VA269 has an exciting journey ahead. Loïc and I will be with you all the way. Of course, we'll be seeing a lot of our rockets on the pad before liftoff, the 64 version with its 4 new boosters attached.
We'll also go to the Launch Control Center. We'll see the teams who are preparing right now all the operations for the rocket and for the launch pad.
And we'll also be heading over to Europe, back in France, where the teams at what we call Space Code will be working in parallel and alongside their colleagues in Kourou.
Yes, and in Kourou, in French Guiana, we'll see also the Quick Look telemetry team, which is in charge of collecting all the precious data coming from the launcher once it has lifted off. And you can see them on your screen. They will monitor every heartbeat of the launcher during the whole mission.
Absolutely. But let's go back inside the Mission Control Centre now, into the fishbowl, as we call it, the protective glass, and to the head of the flight desk, David Cavallolis. David is the CEO of Arianespace. David, thank you very much indeed for coming to talk to us. David, how are things looking for launch?
Hi, Katie. Things are looking excellent today. All systems are working nominally. The teams have completed all preparations and the weather conditions are good for launch today. So Ariane 6, with its 4 brand new boosters, the so-called P160, is ready to fly.
Well, that's good to hear. So tell us a little bit more about our passengers, David.
So today, Ariane 6 carries on board 36 satellites for our client Amazon LEO. Amazon's ambition is to provide high-quality connectivity services all over the world, and I must say that we are very proud to be their partner. So today's mission is very special for us because this is the third in 4 months that we are doing for Amazon, and also because this is the heaviest payload ever to be deployed with an Ariane launcher.
Indeed, and it's also the 8th time that the Ariane 6 rocket will have lifted off from the pad at the Guyana Space Centre. Why is that so important, David?
Simply because with this launch we are confirming the excellent ramp-up of Ariane 6, a very fast one. And also because with this upgrade of the boosters, we are demonstrating our ability to keep upgrading the rocket to ensure it fully matches the needs of our customers, especially when it comes to deploying large-scale constellations.
David Cavallolis, thank you very much indeed, and best wishes to everybody now and your teams. So Ariane 6, the rocket, has actually been designed to constantly evolve, hasn't it?
Yes, indeed. From the very beginning, Ariane 6 was conceived to be able to address a great variety of missions, whether it is orbiting around the Earth, like we are doing today, sending scientific missions into deep space, or even closer to us, going to the moon. To do so, we have a versatile version of the launcher with 2 or 4 boosters. We are using the brand new boosters today, so we get more performance and more versatility for our customers, whether they are public or private.
And we're scheduled to lift off in about 27 minutes. What's going to happen after that?
So we will start our journey to space with the ignition of the 4 boosters, the brand new P160C, alongside the Vulcan engine, which is the main engine of the lower stage of Ariane 6. We will fly for about 2 minutes and 20 seconds with the boosters, and then we'll separate them. Once they have completed their task, we will continue our journey with the propulsion of the Vulcan engine, of course. We will exit the atmosphere. At this point, we can remove the fairing, which is protecting now our satellites. They will see space for the first time. The Vulcan engine will burn for about 8 minutes, and then we will shut it down, and it will separate from the launcher, leaving the way to the upper stage, which is equipped of the Vinci engine. The Vinci engine is reignitable, so we will use it 3 times during these missions. The first boost will last about 10 minutes and will be followed by a ballistic phase with no propulsion. And once we have reached the skies above New Zealand, we will have a second small boost to put our rocket and satellites onto a circular orbit, and that's when we will be able to separate the Amazon LEO satellites. We have 36 of them on board today. We will separate them 3 by 3, so 12 steps during this separation sequence, which will last about 25 minutes. And once the commercial mission is completed, there's a new step for Ariane 6, which is, again, a ballistic phase and a third and last boost of the Vinci engine to decrease our altitude and slow down our speed to re-enter inside the atmosphere over the Pacific Ocean. This way, we won't leave any debris into space.
So that's the plan for today's flight. Right now, of course, our satellite's tucked up inside the top of our rocket, waiting to start their journey. And today is a very big day because it will mark the 100th Amazon LEO satellite to be launched by Europe.
Yeah, an exciting milestone. And the name Amazon LEO is a simple nod to the low Earth orbit LEO satellite constellation they're building. So basically a constellation of satellites close to Earth to connect the world by delivering fast and reliable internet to people, businesses, communities that are beyond the reach of existing networks.
Let's take a closer look at the Amazon LEO network.
Amazon LEO. Several years ago, Amazon set out to build the most advanced satellite system in the world. From the ground up, they designed and built everything. The satellites, the customer terminals, and the network architecture to connect them all. Relentless work, precision, innovation, and commitment. Built over years of focused effort. Today, this team wakes up every morning driven by the same ambition. Delivering fast, reliable internet to people, businesses and communities beyond the reach of existing networks. What started as a vision is now in production. A single system built on 3 pillars: ground infrastructure, satellites operating low Earth orbit, and high-performance customer terminals designed for every need. Amazon LEO is scaling fast, building a new era of internet with full-rate satellite production running and over 100 launches on its manifest. Tonight, Ariane 64 returns to the launch pad, carrying the next batch of Amazon LEO satellites. From Europe's spaceport in French Guiana, this mission carries the partnership aboard Ariane 6 into a new phase of expansion. Larger, faster and more powerful than before. For the first time, Ariane 64 flies with upgraded P160C boosters, enabling the launcher to carry even more satellites, 36 in a single mission. The largest Amazon LEO payload launched to date aboard Europe's rocket. Behind Amazon LEO lies a massive effort. Satellites manufactured at full rate in Kirkland, Washington, prepared for shipment at Amazon LEO's facility in Cape Canaveral, and making the journey to French Guiana before being integrated and launched in planned batches. Minutes after liftoff, another group of spacecraft will join more than 300 satellites already in low Earth orbit, helping deliver fast, reliable connectivity to customers beyond the reach of existing networks. Amazon LEO is designed to serve them all. As Ariane 64 disappears into the skies, another chapter begins for Amazon LEO. Designed to serve consumers streaming and connecting at home, enterprises powering cloud operations across continents, and public sector agencies delivering critical services in underserved regions, Amazon LEO is moving closer to a world where distance matters less, anywhere on Earth. Stay tuned from Kourou.
Europe's biggest technology and innovation event, VivaTech, starts today in Paris. So if you happen to be planning to attend, I highly recommend that you visit the Amazon booth.
Yeah, I'm sure they'd be delighted to welcome you and talk you through the technology.
I think they really would. One of the key people behind Amazon LEO's growing constellation of low Earth orbit satellites is the Vice President of Amazon LEO Business and Product, Chris Webber. Chris has been chatting with Arianespace's Aaron Lewis. Over to Chris and Aaron now, just to earwig a little bit on their conversation and find out more about Amazon LEO.
Hi, I'm Aaron Lewis, Vice President for Media and Government Relations for Arianespace here in Washington, D.C. And I'm with Chris Webber of Amazon LEO. Chris, tell me what you do at Amazon LEO.
Yeah, first of all, it's great to be here with you, Aaron. So I really appreciate it. I run the product side, the operations side, and then sales and marketing, the go-to-marketing side for Amazon LEO across our three segments, the consumer segment, the business segment, and the government segment.
You do it all, and that's incredible. Tell me what differentiates these products that you're developing from what exists in the marketplace at the moment.
Yeah, we're really excited to get service to market across those three customer segments. And I think there's 3 or 4 areas that I would talk about. First of all, just on the innovation side, and I'd start with performance, and we've talked about this. We'll have industry-leading performance. We'll be able to deliver over 1 gigabit on the downlink and over 400 megabits on the uplink. And so that is industry-leading performance at those speeds. The second thing I would talk about is just the value side of things. And that's, how do we think about the performance and price and doing it the Amazonian way and delivering incredible value to our customers, all those customer segments. The third thing on the innovation side, I would say we've really put a lot of innovation on the antennas, the customer antennas.
Yeah.
Our Ultra antenna on the high end, which primarily would be used for government and business customers, is what allows us to deliver that gigabit on the downlink, 400 megabits on the uplink, full duplex. That is industry leading. And then we will have the smallest LEO antenna that's ever been made. It's 7 inches by 7 inches. We call that our nano antenna. Again, it would be incredible for portability, mobility, those type things. So tons of innovation there. And then as you look at on the business and government side, the security that we've woven throughout the network, the encryption, allowing private networking, where you as a customer can select and take your data from the antenna to the satellite into your own AWS data estate or your own data center without ever touching the internet and not requiring a VPN. We're really getting a lot of positive signals. That comes in the forms of we're signing deals, we're announcing that we've announced deals with Delta Airlines, DP World Tour, Vanu, Vodafone, NBN in Australia. So we're really excited about the differentiation we can bring those 3 customer segments, and we're getting great signal and feedback from our customers as we're going to market.
Yeah, life-altering things.
Absolutely.
For the better.
That's right.
Well, this launch is happening from European soil on a European launch vehicle, the Ariane 6. What does this signal for opportunities that you are looking at in Europe for Amazon Leo?
First of all, I have to say, you have been a fantastic partner.
Thank you.
The other thing I would say is we're building this global network and constellation. And I would say Europe, in particular, your company, is contributing significantly to that. So I look at this as this global constellation. This is really about European innovation, European engineering, and European ambition, and contributing in a massive way to building this global constellation.
And on this launch, we're going to be delivering 36 Amazon Leo, the most Amazon Leo satellites that we've had on Ariane 6.
Very exciting.
To date. What does this mean for the deployment of the constellation?
Yeah, it's huge for us. I mean, that'll get us over 360 satellites in orbit. One of the things that we've talked about is we're going to start launching our service in the coming months. And this launch is critical to get us there, as is the other 15 that we'll have with you as well. But the exciting thing for us is, we have hundreds of customer terminals already being tested internally through employees. We'll start to work with government and enterprise companies, and then we'll start to launch service, what we said, in the coming months. And so this launch is critical to that. And so everything we're doing is now testing the network, starting to, what I would call it is just broad acceleration on the network side, our customer terminals, manufacturing those at scale, building our commerce systems, et cetera. And so everything that we're doing now is accelerating as we launch that service. We're really excited about that. This one's critical for us. We'll get that service in market and then just continue to expand from there.
Wow, that was fantastic. Well, it was very illuminating, and it was a pleasure to talk to you about this today, Chris. Thank you.
Thanks so much, and appreciate the partnership.
Yeah, absolutely.
So let's turn our attention now to our new boosters, which are allowing us to carry those extra Amazon Leo satellites.
Yes, and they're truly a great demonstration of European industrial expertise involving a lot of companies in Europe. And the P160 booster is developed by Europropulsion, which is a joint venture between Avio in Italy and ArianeGroup of France. It's been developed for the European Space Agency.
Let's hear from the European Space Agency now.
Today, with these 4 P160Cs on board, Ariane 6 and Europe are going bigger, stronger, and further than ever before. With its predecessor, the P120C, we already developed the most powerful monolithic composite solid rocket boosters in the world. And today, we are reaching a new step. In the future, they will bring as well additional performance to Vega C. This is a true European realization, reflecting a broad collaboration across the European Space Agency member states. This is also a new step in the 40 years of remarkable history of solid propulsion in Europe, built in particular thanks to the French and Italian major industrialists, ArianeGroup and Avio, together with their joint venture Europropulsion and Regulus. But the P160C is a larger European realization. It includes Belgium through SAPCA and Thales Arianespace, Spain through Airbus Defence and Space, Germany with MTA, and Norway through NAMO. You see, this program truly embodies the European Space Agency spirit of cooperation, bringing together expertise, industrial know-how, and shared ambition across Europe. This means we, as Europeans, can go further and do more, support missions to the moon, reach destinations such as Lagrange points for missions like Envision, launch the second generation of Galileo satellites. In a few months from now, we will launch the Plateau mission for the European Space Agency science program, with the objective to find exoplanets. As you see, this is a real step forward. It strengthens both Ariane 6 and Vega C. It gives Europe a more flexible and capable launcher family. The objective is clear: to ensure that Europe remains competitive, autonomous, and ready for the future of space transportation.
So you can see how important those boosters are for all kinds of missions. Let's dig into a little bit of detail about them now. And joining me to do that is André Lafont. André is the program manager for the Ariane 6 boosters. So you're absolutely the right man for the job to tell us all about them, André. Thank you very much for being with us. Let's start with why. Why did we need a new booster?
So for 2020, the need for large constellation in low orbit clearly highlights the fact that Ariane 6 will need more performance. So we studied the different options for this increase, and one of the most quickest and effective solution was to increase the solid rocket motors, in fact. We identified, of course, other solutions, improvements we are working on now, and they will be implemented in the next evolution of the launcher. So with this first increase, this first step, we increase the performance from 10 to 15% in low orbit, depending on the mission. And as you already said, that means that in practical terms, we will launch 36 Amazon LEO satellites today instead of 32 in the two previous missions.
And how did you give them that extra power?
We just had to 14 tons of propellant on each booster. That means that now the weight of the propellant of each booster is 156 tons. And to do so, of course, we had to add one more meter on the motor case of the engine, but we reduced also the forward skirt of the booster for 1 meter to keep the same length of the booster, 22 meters, and also to keep exactly the same interfaces with the central core of the launcher. So that means that all the assembly of the launcher on the pad is exactly the same than previously.
And it must have been a huge team effort getting them ready in time.
Yes, of course. So we worked with our main partners on this project. So it was MTA, Airbus Spain, and of course Avio and our joint subsidiaries, Regulus and Europropulsion. And certainly the major step of this development was the static firing test of the first P160C. We had in April 25 in Kourou at the BEAP, so the large test bench operated by CNES, in fact. So yes, we worked hard together, and with the support of ESA, of course, and we achieved to qualify this new booster and the launcher with this new configuration in less than 4 years.
And did you have to change how you actually manufacture the boosters?
Yes, of course. So we have to adapt all our supply chain on main production means in all the partners. And also in Kourou, with the assembly line, we have to upgrade in Europropulsion, but also on the ArianeGroup building to be able to produce these new boosters. And CNES also had to requalify the transportation of this heavier booster on the Fardier, so the extra large truck we have in Kourou, and which allow to move boosters between buildings and up to the ZL. So I think now all is ready for flight. So I think we are all excited to see our new booster flying.
You must be, after all that hard work. Well, listen, very best wishes to you for the launch. André, thank you very much indeed.
Thank you, Katie.
So we are on the northeastern coast of South America, the Amazonian coast of South America. We've had the latest weather check. You can see the skies are very blue and very beautiful. It was raining yesterday, but today we seem to be lucky with the weather in terms of the camera views, hoping to get some really nice shots of our launch today. But of course, rain isn't a problem, is it, Loic, for us if it's raining? And it does rain a lot here in the Amazon rainforest, but
it does, yes.
There are other things we need to monitor.
The rain is not an issue, but we need to monitor two main things. First of all, the wind, and in terms of speed and direction, mostly for safety reasons. We control these winds, and of course the storms, the lightning strikes, the lightning hazard. Right now, the launch pad is protected by 4 metallic towers that you can see around the rocket, so it's safe. But once we are up in the skies, of course, we don't want to be struck by any kind of lightning that would damage the electronic equipment. So.
And how do you monitor the weather? What systems do you use?
So we do have a full weather station in Kourou with a staff that is in charge of checking several times during the preparation of the launch the weather forecast. To do so, they are using balloons that they inflate. They, of course, are equipped with a lot of sensors. So they send these balloons into the sky and they report precious parameters like temperature, humidity, and wind speed, and so on.
Getting some nice shots there of the weather centre, and very, very important work that they do there. So the teams have been working here at the Guyana Space Centre for, a couple of months now, preparing the rocket and the satellites for today's launch. We call this whole process the launch campaign. And it's a very, very important process with teams, of course, living on site, and no doubt a lot of camaraderie. Our cameras have been following some of the main events during the launch campaign, Loic. Why don't you talk us through what people have been doing?
Sure. First of all, the 36 Amazon LEO satellites have arrived to French Guiana about 2 months ago. They were transported to the Space Center and prepared in their own facilities. And a month ago, the main elements of the launcher Ariane 6 have arrived by boat to French Guiana. They have been transported from the port of Paracabo to the Space Center. You can see here the two main stages being exited from their containers. So you got the lower stage and the upper stage. The first great step of the assembly of the launcher, of course, is to assemble these two stages together. It is realized by the teams of ArianeGroup. It's a very precise operations. You can see that it is done horizontally. And once these two stages are assembled, they constitute what we call the central core of the rocket. It is then transferred to the launch pad, to the mobile gantry, this very big building that you see, which is hosting the rocket during its final assembly. The mobile gantry is a very huge building, higher than the Statue of Liberty and heavier than the Eiffel Tower. So it's a massive building to retract from the launcher once we are in the final chronology. The solid rocket boosters, the 4 of them, are prepared separately in a safe zone in the launch center, and then they are accommodated along the main core of the rocket. Of course, once we have this assembly performed, we have the last great step of the mission, which is the arrival of the satellites. They have been prepared, as I said, separately in facilities dedicated to them, and then encapsulated, as we say, inside the fairing. And the whole thing is transported to the launch pad area. And then, of course, the fairing is put on top of the central core. It marks, of course, the last great step of the assembly of the Ariane 6 launcher. A lot of checks and final things are settled after that, but we have now Ariane 6 ready for launch, and the heaviest launcher ever launched from French Guiana today.
Yes, indeed, quite a record. The heaviest launcher with the most powerful boosters also launched from here.
Yes, indeed.
Yeah, so there they are on the pad, waiting, the satellites inside the rocket, waiting to start their ride. And all eyes in the control rooms on these boards. These are the status panels. They're showing us the live go, no-go status of all the systems across the base.
Yes, it's a synthesis of the parameters of the launcher, the launch base, and the satellites. So everything is green, means that we have the green light for launch.
À 12 DDO, attention pour la séquence finale, lanceur. Top, à 0, moins 5 minutes.
So our range operations manager, Axel Serg, has announced the beginning of the synchronized sequence. This is an important milestone. It's the last 5 minutes of the countdown. We often call it the automated sequence as well. Everybody across the base, of course, will be listening out for Axel's voice throughout today's launch. Right, lots of very important operations happening now, aren't there?
Yes, it's basically the final race for the preparation to lift off. Right now, we have many operations going on. The computers are taking the lead over the humans. We are activating valves, checking pressures, activating currents, avionic equipment, and of course also monitoring very closely the safety aspects. So these 5 last minutes are really the final preparation, and it's getting the launcher autonomous step by step.
You can see there that the spaceport is a big place. Nice shot there of the engine on the main stage, the Vulcan engine. It's a big place, lots of facilities, several different launch zones. We've got satellite preparation buildings, offices. We call the whole thing the range, and we have a couple of important control rooms here at the spaceport on the job today. We've been looking at mission control. Of course, the other one is launch control. What are they doing in there, Loic?
So in the launch control room, you have all the teams that are in charge of the operations. They've been working for many hours now. They are located 5 kilometers from the launch pad, so pretty close from the pad, and they are in the reinforced concrete building that protects them, of course, from the blast of the launch. They've been doing the commands for filling the tanks, pressurizing the system, do all the planned checks for the launcher to get ready. And all these engineering teams are monitoring all the parameters right now, temperature, pressure, electrical currents, and so on. And they are backed by a support at the Space Code in France. So we have extra brains in the headquarters of ArianeGroup to help if it is needed, of course, in case of any mishap just during this last sequence.
Indeed, and laser focus now for everybody in all of these control rooms. Nice shot of the pad there. We can see the lightning towers, and on the right-hand side, right and left of your screen, you can just see the concrete structures. Those are the flame trenches there. Great shot of that flame trench. It's where the fumes will come out at liftoff. And then 3/4 of the way up, those yellow structures are the cryogenic arms, and they're clamping onto the rocket, and they're feeding very, very cold propellant in.
Absolutely. We are using cryogenic oxygen and hydrogen as propellant for the lower and upper stage. So liquid hydrogen is minus 253 degrees Celsius, liquid oxygen minus 180 degrees Celsius. So very, very cold. And we fill up the tanks until 3 minutes before the launch. Of course, at the time of liftoff, the yellow arms will retract and will leave the way for the launcher to ascend.
So you can watch out for those. You'll also see the umbilical lines disconnecting and pulling away as well at the moment of launch. And you can also count to 7 when you see the first ignition, because we switch on the Vulcan engine on the main stage before the boosters, don't we?
Absolutely. 7 seconds, as you said, before the ignition of the boosters, we have a verification on the Vulcan engine, making sure that it works perfectly, because once we ignite the 4 boosters, there's no way to hold back the launcher. So we want to get ready for every system at the lift-off time.
À tous de DDO, attention pour moins 1 minute. À tous de DDO. Arrêt du temps des comptes suite à un rouge. Ensemble de lancement. Que tous les moyens restent prêts pour la reprise de la chronologie. À Giro, moins 5 minutes.
Okay, so he has just announced that he is stopping the countdown.
Indeed, yes, we had what we call a red. So here it's the launch range and launch base that is saying that something is not nominal as a parameter. So we are holding the countdown right now, and we'll stay tuned to the launch operation manager to know when we can retarget another lift-off time. We have a launch window today, meaning that we have a few minutes, about 29 minutes today to perform the launch, so we can solve any very minor mishap if needed.
And you can see the status panels on the left-hand side of your screen there, the red status panels at the top. Ensemble de lancement means the launch base, or the range.
Yes.
I believe. So what we'll do now is we will cut our microphones and come off air just briefly and come back to you when we get some more information.
À tous de DDO. Suite au retour au vert, le nouvel âge gyrovisé sera 12h21 minutes 52 secondes. Le TD redémarrera à 12h16 minutes 52 secondes. À tous de DDO, attention pour la reprise du temps des comptes.
Right. You are joining
Top,
us
début de la séquence finale lanceur.
on Road to Space. We are live.
Nouvel âge gyrovisé, 12h21
We are live at the
minutes 52
Arianespace
secondes.
Centre, the European spaceport in French. Right, so the Range Operations Manager has just announced a new launch time. We had a stop in the countdown, and we are launching the next 36 Amazon LEO satellites. They are sitting nice and safely and nice and comfortably in first class in the top of the rocket under the bonnet. Nice shot there of our Ariane 6 on the pad with its 4 new boosters. Now, we had a stop in the clock, Loic, about 1 minute and 50 seconds roughly before launch.
Absolutely, yes. We have what we call the status panel, the panneau des verts in French. So as the name says it should be all green to authorize the launch. It basically synthesizes all the parameters on the launch base. There are so many parameters that we monitor until the very end of the chronology, until the liftoff. So if one parameter is not according to plan, is not normal, we stop the sequence, and that's what happened a few minutes ago. Apparently, we are now able to target a new lift-off time because we have what we call a launch window today of about 29 minutes. So we have, let's say, extra margin to resolve very last-minute mishaps like we had just before. And so we have now a new lift-off time.
And the status panel which turned red was what we call in French ensemble de lancement, which means the base.
Yes, the launch base. So, of course, many systems are involved. You have all the. If one of them is not ready for launch, of course, we halt the chronology, and we are able to restart from.
Today is Axel Serg, and Axel has just announced the new launch time, which I've noted down as 12:21, 50 seconds, or maybe 50. I didn't quite hear the end of what he said. So just to explain to anyone who might be joining us, we have what we call a launch window today, don't we? Which means we have a lift off.
Yes, during some missions, we have an instant time of liftoff that is unique. So in this case, we have to launch at the right moment. For this launch deployment of Constellation in low Earth orbit, we have a little bit more flexibility. And as you said, the launch window allows us to have a little bit more time to target a launch instant in this launch problem. And that's what happened just before. So now we are 2 minutes before the new liftoff.
Launch. It's a really lovely place to watch it.
I think everybody is very impatient to see the launch.
Yes, yes, and look, it's a very stunning, beautiful water tower. Of course, the water will flood the pad at liftoff to dampen the acoustic vibration. Mark and all the invited guests going out onto the balconies to watch the launch.
À tous de DDO, attention pour moins une minute. Top, A0 moins une minute.
So we are 1 minute to launch. Our very best wishes now to start their journey.
Bon voyage Ariane 6 and bon voyage Amazon Leo.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Allumage ESR et décollage. La propulsion est nominale. La propulsion est nominale. Pilotage calme. Trajectoire nominale. La propulsion est nominale.
The Ariane 64
Passage du transonique. Trajectoire nominale.
Space Center.
Yes, very impressive images.
Journey on board Europe's most powerful version of Ariane 64 yet.
A beautiful sky today to see the launch.
La trajectoire est nominale.
Very nice.
Yes, indeed. It's a very, it really is a very wonderful thing to see. The rocket and the sound of the rocket.
Propulsion
Doing
nominale.
all the work right now, Loïc.
Pilotage toujours calme.
%90 of the thrust at liftoff.
La trajectoire est nominale.
Each booster carries almost 160 tons of solid propellant, and they will burn in about 2 minutes.
Chaque propulseur environ 156 tonnes de carburant et ils vont être allumés pendant plus de 2 minutes.
Séparation des ESR. Fin de rattrapage, début du mode barbecue. Trajectoire nominale. Séparation coiffe. La propulsion est nominale. Le pilotage est calme. Trajectoire nominale. La propulsion est nominale. Le pilotage calme. Trajectoire nominale. La propulsion est nominale. Pilotage calme. La trajectoire reste nominale. Propulsion toujours nominale. Pilotage calme. Il reste 2 minutes de propulsion Vulcain. Propulsion nominale. Pilotage calme.
We give the maximum thrust we can expect to have the propulsion of our.
Trajectoire
flame
nominale
of the
et
Vulcan
acquisition de la
engine.
télémesure
It's
par
very
la
powerful.
SNA.
It is, yes. It is inherited from Ariane 5 technology. It has been, of course, improved for Ariane 6 with major optimization. For instance, the nozzle manufacturing has been completely done differently, and we have a gas generator using additive manufacturing, so the very latest technology.
Il reste 1 minute de propulsion Vulcain.
We will burn 154 tons of cryogenic propellant in about 8 minutes. We will reach around 270 kilometers. At that point, we will be able to shut down the engine and separate the lower stage since we don't need it anymore.
A quick word on the top right of your screen. The green line is the trajectory, planned trajectory. The yellow line is the actual trajectory, and the cross is the actual position of our rocket. Below that, you've got our altitude, our distance from the pad, and our speed in kilometers per second. We are tracking the rocket using telemetry. We have ground stations dotted along its flight path, and as the rocket flies over, it sends a signal to those ground stations. So effectively, it's kind of talking to us. It's communicating with us.
Yes, it's really important to have to keep track of the launcher, where it is, how it's behaving, and to do so, the launcher is constantly sending signals to those tracking stations that are on ground, but not only on ground. We have one also in the Atlantic.
Yes, in a boat.
In a boat. The Naval Tracking Station. It's a boat equipped with large antennas, stabilized, of course, in case the sea is a bit rough. And it's a really precious mean of communication that allows us to keep always contact with the launcher.
And this is the sequence now, the separation sequence of the main stage. You can see it there falling away. It's burnt its propellant. That great big tank of fuel now empty and being jettisoned. And you should see on the camera images the engine of the upper stage switching on. The engine is actually on the right-hand side. You can just see it warming up, heating up there, getting redder and redder.
Yes.
Yeah, as it burns. So we are now very much in the next phase of our journey because the upper stage has switched its engine on, and that's an important moment, isn't it?
Yes, always a critical moment, of course, to switch on and off an engine. So right now we are starting the next big steps of the mission. Allow me to say that the images are incredible right now. I'm a bit mesmerized. So critical time indeed, and we are now raising again our altitude. We will place the rocket and the satellites onto a kind of intermediate orbit, an elliptical orbit. We will have propulsion with the Vinci engine for 10 minutes, and we will shut it down then, and then we will have a ballistic phase, so no propulsion. We will talk a little bit about this later, but now you can just enjoy the view.
It's quite fun, isn't it? Looking here on the left-hand side of the screen is our real camera images from the cameras on board the rocket, and then on the right-hand side our animation, the 3D simulation of what's been planned for today's mission. So most of the Ariane 6 rocket is actually built in Europe, isn't it? And some of it here we're in the ArianeGroup. And the sections are actually transported to French Guiana for assembly at the spaceport. They travel by boat, but it's not just any old boat, is it? It's a really special boat because it's actually got sails, and that's not something that we see very often these days.
Yes, indeed. The name of the boat is Canopé. It has a hybrid propulsion system using both fuel and wind power with its 4 wing sails. And the fact that it uses the wind power enables us to save up to 40% of the fuel we would use with a regular mean of transportation. And it's an important step, of course, to reduce the carbon emission of all the transatlantic crossing that we do for the Ariane 6 project. So the Canopé boat has been sailing all around Europe to collect the different sections of Ariane 6 in the different location of production of the components, and of course carried them to French Guiana for the assembly and the launch day. Canopé has been designed to transport very large but also very fragile components at sea, whether it's rough or calm, and also in the very shallow waters of the Kourou River in French Guiana. And Canopé in English translates to canopy, which is a nice nod to the Amazonian rainforest, of course.
The very beautiful, lush canopy of the Amazon rainforests. which any of us who work there regularly are privileged enough to see. It's stunning. So our speed and altitude, we're travelling above 6 kilometres per second, Loic. Do the maths for us. What's that?
You need an engineer for that, maybe?
Yeah.
Okay, it should be something like 21,600 kilometers per hour. And for American viewers and British reviewers, that would be 13,400 miles per hour.
Okay. And our flight path, where are we flying over?
So we left, of course, the coast of French Guiana. We are across the Atlantic now. We will head towards Central Europe, and we'll go on the other side of the Earth and down to Indonesia and Australia. We will fly over New Zealand as well. We'll catch there another ground tracking station to allow the second boost of the Vinci engine. And then we will fly again towards South America, and that's when the separation sequence of satellites today will happen. And after the commercial mission is completed, we will also have another lap of the Earth with what we call the passivation and re-entry phase. So we will have the launcher upper stage go down to the atmosphere so we don't leave any debris into space.
You can see the operational teams there on the bottom right of the screen, and we could see the teams back in the Launch Control Centre before that. Now, the tracking stations, they collect the information from the rocket, and they then relay it back to the Guyana Space Centre, to the tracking station there. It's called Galileo, and in there, the Quick Look telemetry team, you can see them now, are working very, very hard at this point now after launch. Their job really starts after liftoff, doesn't it? What are they actually doing?
Yes, and an important job that they are doing now, they are collecting all the data in real time coming from the launcher. So whether it be status of the engine or, of course, the trajectory parameters, knowing where the launcher is. Any kind of flight control command, they are reported through telemetry to them, and they make a synthesis to the Mission Control Center, making sure that they report the actual behavior of the launcher. And they also compare the data to the prediction. So they want to make sure that we are in the right prediction model and that everything is going according to plan. I can see some familiar faces on the screen here.
Yes,
they are very
indeed.
focused.
Yes. And yes, I mean, the room itself could maybe do a little bit of decorating, but it doesn't belie the importance of the role that this team is playing. So the teams now at the Santa Maria tracking station are monitoring our launcher as it flies over their patch. Santa Maria is a very beautiful island. Apparently it's got lovely white sandy beaches, and it's in the Azores. In the Atlantic Ocean, so probably quite a nice place to go on holiday.
Probably, yes. I'd like to go there. But also, it's nice, but it's also very useful because it has clear horizons on the Atlantic. So it means that we can catch a signal of the launcher very quickly and in a stable way because we don't have bad weather conditions and we have very little radio interferences. So Santa Maria is essential for Europe's launch and tracking chain, and it's part of a wider worldwide network of ground tracking stations that are made available by the European Space Agency.
So it's a small place, but it plays a very big role in getting not just launches off the ground, but rockets across the water, across the pond. So the Ariane 6 upper stage's engine, you can see it on our simulation there, the visualization burning its blue flame. It's the Vinci engine, and it's powerful, but it's also very sophisticated.
Yes, it's a brand new design for Ariane 6. We have a cryogenic engine that is reignitable. It's the first for the Ariane family. And we can switch it on and off up to 4 times. And the very interest in this feature is that we can address many varieties of missions, so we can go either to low Earth orbit and deployment of constellation as today, or we can target medium Earth orbit, direct GEO orbit, so geostationary orbit, or even escape orbit if we want to do some scientific mission to the and liquid hydrogen. And we will use the engine twice today for the injection of the Amazon satellites into orbit.
operations manager telling us that everything's going normally. Let's do some more maths, Loic, because we're now at we're 7.5 kilometres per 7 now. We really, really are going fast, aren't we?
Yes, almost the fastest we will go today. We are about 27,000 kilometers per hour, 17 miles per hour, 17,000 miles per hour. That's almost Mach 22 times the speed of sound, so pretty fast.
Pretty fast. But of course, Mach 22 in the vacuum of space is not like Mach 1 in the dense part of the atmosphere. You don't feel it in the same way. So the next moment will be switching off the Vinci upper stage engine. That's coming up in about a minute's time. Why will we do that? Why will we need to switch it off?
So right now we are placing the rocket and the satellites onto an intermediate orbit. You can see that we are decreasing our altitude. We are getting closer to what we call the perigee, the closest point to Earth. We have an orbit that is elliptical, kind of the shape of an egg, if you want. The closest point, the perigee, is also the point where we accelerate the most. And then this acceleration will enable us to go further in altitude, and we will have the furthest point of the trajectory, which is 465 kilometers at apogee. And this altitude of 465 kilometers is precisely the altitude we are targeting to deliver our satellites. So once we have climbed up to this furthest point, we will have a second boost, very short boost of the Vinci engine to transform the elliptical orbit into a circular orbit.
Le pilotage est calme.
Up there in space, the scheduled switch off of the engine, and the range operations manager telling us that the piloting is calm. So we have now switched our engine off and reached the first major step, I guess, in reaching this target orbit. We're actually in what we call the ballistic phase. As you mentioned, we're travelling without propulsion. We are coasting without the engine, and we've got a really nice shot there of our satellites attached to their dispenser. 36 satellites, looking a little bit like a corn on the cob.
Yes, if you want so.
Yes, yeah. And they will be all separating later from that dispenser, but right now they're still on their way to their separation orbit. And the next ground station to pick us up will be in the southwest of France. It's called Ossagal.
Yes, in the south of Toulouse, in southwestern France. Toulouse, of course, is a great city for aerospace industry, a lot of industrial there. There's also a very interesting exhibition center, which is called Cité de l'Espace, City of Space. So if you're a space geek or if you are remotely interested in space topics, make sure to pay a visit to this exhibition. It's really interesting.
Yeah, highly recommended, definitely. So we're going to take a break now. We're going to take a break for 45 minutes. That means we'll be coming back to you at about 12:57 GMT, Greenwich Mean Time. That's 2:57 in the afternoon in Paris. That's 9:57 in the morning at the spaceport in Kourou, and 8:57 in Washington. So we'll see you back here then.
Stay tuned.
Propulsion nominale. Pilotage calme. La propulsion est nominale et fin de visibilité de la télémesure par la station de Santa Maria des Açores. Pilotage calme. Propulsion nominale. Pilotage calme. Propulsion nominale, pilotage calme. La propulsion est nominale. 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 Pilotage calme. Fin de visibilité par la station d'Ossaguel et perte de la télémesure attendue. Retour de la télémesure dans environ 28 minutes. Ok, nickel. Et là, je parle dans le micro antenne en rouge. Ok, nickel. Là, je suis sur le micro de Loïc. Oh. Acquisition de la télémesure par la station de Nunorcia. La propulsion est nominale. Le pilotage est calme. La propulsion est nominale. Le pilotage est calme. Propulsion nominale. Pilotage calme. La propulsion est nominale. Le pilotage est calme. La propulsion est nominale. Et le pilotage est calme. La propulsion est nominale. Le pilotage reste calme. La propulsion est nominale. Le pilotage est calme. La propulsion est nominale. Le pilotage est calme. Propulsion nominale. Pilotage calme et fin de visibilité de la station de New Yorcia. Perte attendue de la télémesure. Retour de la télémesure dans 2 minutes. Acquisition de la télémesure par la station d'Awaruya. Le pilotage est calme. La propulsion est nominale. Le pilotage est calme. La propulsion est nominale. Le pilotage est calme. La propulsion est nominale. Pilotage toujours calme. Le pilotage est calme.
Stunning images of Ariane 64 launching from the European Spaceport in French Guiana just over an hour ago. Welcome back to Road to Space. I'm Katie Haswell.
And I'm Arianespace from Arianespace.
And our rocket, Ariane 64, is hurtling through space with our 36 Amazon LEO satellites inside. I think I might have some sound problems, so you pick up.
Okay, so we have our satellites traveling on board Europe's most powerful rocket, Ariane 64. Today is the 8th flight of Ariane 6 and the 7th flight for Arianespace to operate this launcher. And as you said, Katie, we have 36 Amazon LEO satellites on board, and we are now approaching an important sequence, which is, of course, the separation of our satellites. We will now do a transition from the elliptical orbit on which we are on to a circular orbit. We are just pick up the signal in the Awarua ground test station over New Zealand. You can see on the CGI animation that we see New Zealand beyond the launcher. The launcher right now is composed of the upper stage, equipped with the Vinci engine, and on top of it, you have the 36 Amazon LEO satellite assembled around the dispenser.
And let's just have a little reminder now of what's been happening so far, Loic, and what's coming up.
So we lifted up about an hour ago from the coast of French Guiana towards the North Atlantic Ocean. We have been propulsed by the 4 boosters, which are brand new on this version of Ariane 64, the P160C, enhanced boosters with more thrust. We have separated them once they have completed their task, of course, and then separated the fairing. Once we have exited the atmosphere, the satellites are now in visibility of the deep space. The Vulcan propulsion, the main engine propulsion, has lasted about 8 minutes. After that, we have separated the lower stage to shed up some mass, and then now we are working with the upper stage, which is equipped with the Vinci engine. The Vinci engine is a cryogenic engine that can be reignited several times. We will use it 3 times during this mission. We have already performed the first boost of 10 minutes. And after that, we had a ballistic phase when we have raised our altitude just by the simple effect of gravitation. We are now on an elliptical orbit, almost at the apogee at 465 kilometers, which is the targeted altitude to deliver our satellites. And this is the main coming up sequence, of course, the separation of our 36 Amazon LEO satellites. 12 steps for that separation. We separate them three at a time. And once we have completed this separation sequence, the commercial mission will be over, of course. But for Ariane 6, there's going to be another adventure, which is the re-entry into the atmosphere after a third boost of the Vinci engine.
And on the top right-hand side of our screen, you can see the trajectory. The green line is the planned trajectory, and the yellow line is the actual trajectory. And the cross, of course, is our rocket. Below that, our altitude, 464 kilometres, coming up to 465, and our speed, 7.5 kilometres per second. That's very fast. Coming up now to the next big moment.
Deuxième allumage Vinci. La propulsion est nominale. Pilotage calme.
And we have confirmation from the range operations manager that we have now switched on the engine on the Vinci upper stage for its second boost. So that's good news. It's a short boost.
It's a very short boost, 18 seconds, just enough energy to transform the elliptical orbit into a circular orbit, so a constant altitude, which is the targeted altitude to deliver our satellites. You can see on the screen that on the top right-hand corner that the altitude is now plateauing at about 465 kilometers. And we just had confirmation that the Vinci has just shut down, so we are now in another ballistic phase.
And things are about to get interesting now for our Amazon LEO satellites because, as you said, Loic, we're on our orbit, we've plateaued out, and the next step will be to start these separation sequences. And we're going to be delivering 36 satellites, 3 by 3, in 12 separations.
Absolutely, and the onboard computer of the upper stage, of course, is fully autonomous, so it knows perfectly when and where to drop our satellites. Right now, we are outside of the visibility of tracking stations, so the first separation events will not be fully given by the telemetry. We will have to wait for the acquisition of another tracking station in Gallio, in French Guiana. So we will have done a lap of the Earth by then, and it's just about half an hour, and we will have confirmation of all the parameters of the launcher by then.
Indeed. So what we're going to do now is take a break while we wait to go back into the range of the Gallio tracking station at the European Spaceport in French Guiana. And once we've checked in there, we'll come back to you in about 27 minutes, just before we check in, actually. So don't go away. Stay with us.
See you very soon.
La propulsion est nominale. Pilotage calme. La propulsion est nominale. Pilotage calme. Propulsion nominale. Fin de visibilité de la télémesure par la station d'Awarua. perte attendue de la télémesure, retour de la télémesure dans à peu près 25 minutes. Acquisition de la télémesure par la station de Galio.
Hello again, welcome back to Road to Space. I'm Katie Haswell and
I'm Le-03 from Arianespace.
And we've just had confirmation there that we've acquired the signal at the Galio tracking station. So we are just over an hour and a half into the journey of 36 Amazon LEO satellites on board Europe's Ariane 6 rocket.
Yes, they are on their way to join their fellow Amazon LEO satellites in space and grow the constellation for Amazon LEO.
Indeed, and we're scheduled to have delivered the first 18 of those satellites onto their orbits. And if you've been watching our 3D there, the telemetry coming in now on the right-hand side of the screen. And the range operations manager is now confirming that the separation sequence is ongoing. Loic, we have lots of passengers on our bus today, all getting off at different bus stops.
Yes, and the bus driver is the Ariane 6 upper stage. We have now delivered scheduled delivery of many satellites. The upper stage is fully autonomous, so it knows when and where to drop off our passengers. We've been outside of visibility of ground tracking station for a few minutes before, but now we are collecting, as you said, the data coming from Galio ground tracking station. And we have done a lap of the Earth, so it's been quite a ride already. And the separation sequence is progressing. We have 25 minutes of total of separation sequence, and it's performed in 12 steps. So we deliver 3 satellites at a time.
We were just looking there at the bottom right of the screen. We could see the teams at the Galio tracking station in French Guiana at the spaceport, who are tracking these separations at this point now. The next one coming up will be separation number 7, and you can see on the top right-hand side of your screen, that's the trajectory, the green line, the projected planned trajectory, the yellow line, the actual trajectory, and you can see, and the cross, of course, the launcher, and you can see that we've already scheduled to have gone through 6 separations, getting a nice shot there of our satellites attached. Now, just talk us through how it's all working.
So you can see on the animation that the satellites are attached to a kind of mast, this kind of black cylindrical structure, which is the satellite dispenser provided by Amazon. Below the dispenser is a conical shaped structure, which we call the launch vehicle adapter. It connects the dispenser and the satellites to the launcher. The launcher being the upper stage, this white cylindrical structure that you see on your screen. And right now we are progressing with no propulsion from the main engine. We were proceeding, with the separation sequence. So we have 5 more sequence to go, 5 more steps to go.
And the satellites being pinged off the dispenser there with the set of springs.
Yes,
moving.
Indeed, they are moving. They are gently pushed away through spring. The separation command is sent by the onboard computer, relayed by the dispenser, and through pyrotechnical devices, the satellites are released from the dispenser. And as you mentioned, the springs are gently pushing them away and safely pushing them away from the launcher.
That's to avoid any collisions. We don't want anybody banging into anybody else up there in space. That's where we lifted off from, the Guiana Space Centre. You saw it back there. And this image that we're looking at is the visualization. It's an animation. It's a simulation of, he's giving us information there that we have now picked up the signal at the tracking station at the SNA. So this visualization that we're looking at is really great, isn't it? Because it allows us to see what's actually happening up there in space.
Yes, we have all the inputs from the mission analysis as entry to this animation. So you have what is actually happening in space. Of course, we don't have the actual footage, but we don't have external cameras to see that. But you can see the animation is pretty accurate. And once again, on the top right-hand corner of your screen, you have the actual telemetry, so the data that is received live and that is transmitted through mission control. So we know our altitude, and also the speed is right now 7.3 kilometers per second.
And there we go, the naval tracking station. You can see it there. Loic, we are coasting without the engine, but we do actually have a little bit of propulsion, don't we?
Yes, indeed, the Venture engine, the main engine, is shut down, but we have a feature of Ariane 6 upper stage, which is called the APU, the Auxiliary Power Unit. It's kind of a small engine that gives a little bit of thrust to the stage when it's not in the full propulsion mode. It's a very interesting feature because it allows us to perform the deployment of this constellation and 36 satellites in a very safe mode. We have, let's say, the distance between the satellites and the launcher completely under control, and it also allows us to perform this sequence in a rather short amount of time. We have 25 minutes to separate 36 satellites, so it's quite short. And that's one of the innovations from Ariane 6 that is allowing us also to address very various missions.
So as we said, we've picked up the signal at the naval tracking station, which is now monitoring this phase in the flight, and the range operations manager telling us everything's going normally. Yeah, it's a boat, isn't it?
Yes, a boat right inside, in the middle of the Atlantic Ocean. We have seen it at the beginning of the mission. It was helping us tracking the launcher at the beginning of the mission, and we have done now a lap of the Earth, so we are back almost on the same position as before, and we are tracking the launcher again. And it's important, of course, in this separation sequence that we get all the data needed. So the naval tracking station is equipped with large antennas, and they are stabilized, of course, because if the sea is a little bit bumpy, we want to make sure that the signal is not degraded.
Indeed, you want to make sure that even in choppy waters you can still keep it nice and balanced, so it's a clever thing. Big shout out to all the people working in all the tracking stations, actually, because we've got quite a few of them today, haven't we? We lifted off from Galileo, we've got the naval tracking station, we've also got Santa Maria in the Azores. Yes,
we have a full network all around the globe for these ground tracking stations. It's very important. As I said, we need to have a good tracking of the launcher, of what's happening in space, and we have the teams from the Space Agency, French Space Agency, which are in charge of these tracking stations monitoring right now.
Separation number 10 that we're looking at, the Range Operations Manager has been telling us that the separation process is ongoing, and we've gone out of the range now of that tracking station, the previous tracking station. So it's an important day for us, actually, because today is, once we've released our final satellite, will be the 100th Amazon LEO satellite.
Absolutely, yes.
To be launched by Europe's rocket, and it's just a sign, really, of the hugely important relationship between Arianespace and Amazon LEO.
Yes, we are very involved in committing to Amazon LEO's missions. We have 18 missions contracted with Amazon LEO. It's the third one today. So we've been quite busy in the past months to handle all these missions and to send these satellites into space. Of course, we are always glad to have the Amazon teams in French Guiana preparing the launch campaigns, and we have also given them specific facilities so they can smoothly and independently prepare their satellite batches for every launch campaign.
Indeed, it's always a joy to see the Amazon LEO teams in French Guiana. And we have quite a lot of new features, haven't we, coming on Ariane 6. If you were with us at the beginning of the programme, we were explaining how the Ariane 6 rocket has actually been designed to be scalable, to be modifiable, to be constantly upgraded, lots of new features.
Yes, we like to have a launcher that is indeed evolving all the time. Of course, we have all the return of experience of the past missions, which allows us to make it even more performative. But also we have greater improvements, like we're going to make the structure that is holding the Vulcan engine, the engine from the lower stage, much lighter. So this means that we will have more payload to offer to our customers to be brought into sky. So it's always good for our customers to be able to count on Ariane 6 being even more performant.
Nice shot there of a good angle, if you like, camera angle, if you like, on the satellites being separated. Separation number 10 You can see that we've got 6 satellites left on board. Our mast getting increasingly empty. And if you're just joining us, a quick reminder about the Amazon LEO constellation and why today's launch is important, why it matters. Amazon LEO is Amazon's low Earth orbit network, so hence the name LEO for low Earth orbit. And it's designed to provide fast and reliable internet to customers and communities who are often beyond the reach of existing networks.
Yes, and the constellation will be over 3,000 satellites. It is also linked to a global network of antennas and fiber optical lines, of course, and internet connection points on the ground. And the constellation will include so many satellites that will work in a choreographed mesh. They will be, as you said, delivering a low latency connectivity for homes, for businesses, for farms, emergency services, even aircraft.
2 more separation events to go. 6 satellites left, so 2 more separations of 3 satellites each. And our dispenser, that mast, the black mast in the middle there, it's really getting empty now, isn't it?
Yes, indeed, yes. As you said, two more steps to go. We have separated them from bottom to top.
And what we're looking at here, the white disk, is what's left of the rocket. It's the upper stage, and the long mast, if you like, is the dispenser, which not only allows the satellites to be attached, but also allows them to be effectively dispensed, so ejected into space, as you were saying, with that set of springs. The next separation coming up, and that is separation number 11. And the range operations manager confirming that the separation sequence is ongoing. We can see the little satellites there moving away slowly from the mother ship, gently, to go off and join their brothers and sisters in space. And as we've mentioned in the programme, it is an important day for Amazon LEO because we're launching more satellites into orbit than previously. We've got an extra 4 satellites on board, and that's all thanks to our new boosters, the P160Cs, more powerful, more performance. Yeah, indeed, more performance, so more satellites to bring into space, and that's really important for the constellation. The more spacecraft we deliver, of course, is the more useful we are for our customer, Amazon LEO. And so far, in a few months, 5 months, we've been able to launch 3 missions, and that represents, as you said before, 100 satellites launched by Ariane 6 so far. We've got 1 more separation left now. The last 3 satellites waiting to be dropped off at their final bus stop and go off and join the rest of the constellation. The other satellites already heading off. Well, what's actually happening to them now? What happens to them once they're released into space? So they'll start their real life in space. And the Amazon LEO Mission Operations Center in Redmond, Washington State of United States, is taking control over their newly delivered satellites. They will be flying satellites, if you want, managing all the spacecraft operations. So right now they are taking over the mission, establishing contact with their new additions to this fleet. And they will be conducting initial health checks, raising also the orbit of the Amazon LEO satellites to their final operative orbit. And this phase that we call the commissioning phase, once it is completed, then the satellites will start doing their job, which is delivering internet connection.
Poursuite et fin de la séquence de séparation Amazon LEO.
So, the final Amazon LEO separation there, the range operations manager confirmed that was the final one. Let's go over. I see that David Cavaiolas is in the fishbowl. David, of course, is the CEO of Arianespace and also head of the flight desk. David, so the mission's ongoing.
La propulsion est nominale.
Tell us about the progress of the satellite situation.
Hi again, Katie. Hi again, everybody. The mission is still in progress. We only have partial data at the moment, but those data are extremely positive because they show that all the satellite separation that we have been able to track happened exactly as planned. The satellites have reached successfully their target orbit. So this is a milestone, and even if the mission is still ongoing, I would like to thank all the team and congratulate all the team involved. Today we have launched the heaviest European launcher ever, and this is really a turning point. Last but not least, of course, thank you to Amazon. We are more motivated than ever to make Amazon Leo a success.
Well, David, thank you very much indeed. Congratulations to you and to all the teams. Thank you very much, David Caviolis. So, Loic, it was a beautiful launch, and we are coming to the end of our programme now. But congratulations to everyone who's worked so hard on today's launch, and thank you.
Yes, thanks also to all the teams at ArianeGroup and Arianespace, all the people involved at the Guyana Space Center and all over the globe. You've been doing a great job again.
And also massive thanks to the Amazon Leo teams. Our thanks also to the production team who have made this live broadcast possible, and to you for joining us on Road to Space. We're going to leave... Oh, and to you, Loic Leroy, for being with us. Thank you.
Thanks for having me.
And lending us your expertise. We're going to leave you now with a film about Arianespace, and a short film about Arianespace, and a replay of the launch. But for now, from me, Katie Haswell.
And from me, Loic Leroy.
Goodbye.
Goodbye.
The launch starts the moment you partner with us, as we go above and beyond to understand your world from orbit, everything you've ever imagined, the value you bring home to Earth, all the lives you seek to improve. So, whatever your goals, however far you want to go, your success is our mission. More than rockets, we launch ambitions. Arianespace, launching ambitions.
4, 3, 2, 1, allumage ESR, et décollage. Trajectoire nominale.